Example 157.6. Exercise researchers compared the effect of different volumes of training on strength gains in the squat exercise. 33 participants performed either 1 set, 4 sets, or 8 sets of squats. The participants were randomly assigned to each of the groups, and each participant had experience with weight training. The study lasted for 12 weeks, and each participant performed their assigned squat workout twice per week. Participants did not have statistically different 1-rep squat maximums before beginning the study. The following results were produced using Minitab, a statistical software package. Interpret the output. Okay, so let's start with the null hypothesis they've provided us. It's the classic null hypothesis for an ANOVA completely randomized design experiment. It says that all the means are equal versus at least one mean is different. That's the alternative hypothesis, of course. The significance level for the test is 5%, a pretty traditional significance level. Then they tell us that equal variance were assumed for the analysis. That's always the case because that is the assumption underlying the completely randomized design experiment. They go on to tell us that there were 3 levels of set ranges, right? So in other words, the factor that we're looking at is the number of sets, and there were 3 levels for the experiment, either 1 set, 4 sets, or 8 sets. So participants either squatted by doing just 1 set for each workout, so in other words, twice a week they did 1 set, or they did 4 sets twice a week, or they did 8 sets twice a week. All right, so let's take a look at the ANOVA table here now. You can see that under source, they have sets listed as the treatment. They have error, of course, and total. You can see the degrees of freedom for total is 32 because we had 33 participants in the study. The degrees of freedom for sets is 2 because it's the level or number of levels minus 1. So 3 minus 1 gives you 2. Then you can see the error term. Basically, that's just the n, the number of participants, minus k, the number of treatments. So 33 minus 3 gives you 30. You have the adjusted sum of squares, the adjusted mean squares, and then you have the F value, right, which is our test stat, and then we have the P value that corresponds to that. You can see based on this that the F value is quite large, 114.05, and it results in a P value of 0.000, so virtually 0, right? And that's a very small P value. Now remember, whenever the P value is less than alpha, we're going to decide that we reject the null hypothesis, right? And that means the treatment effect is significant. So we're going to reject the null hypothesis here. So we're rejecting this statement that the means are all equal, and that means we're supporting this statement, right? So because we're supporting the alternative hypothesis, it indicates that there is a difference between the number of sets you do when it comes to strength for the squat exercise, right? So perhaps 8 sets is better than 1 set, for example. We can probably say at least that since we're able to say there is a difference. Probably those two extremes have some difference, but maybe not. Let's look at the diagram to see what is actually true based on the statistics. So when we look at the means that they've given us, right, we can see that there's clearly an order here, that the 1 set group had a lower mean value than each of the other 2 groups. The question is it significantly different, right? Clearly the 8 set group squatted more weight than the other groups, right? Their average squat was 436.9 pounds, while the 1 set group was only 369.22 pounds, right? So that does seem to be a significant difference when you look over here at the confidence intervals. But in order to see it more clearly, let's take a look at the diagram they've provided us. All right, so when you take a look at this diagram, it becomes very clear that there is a significant difference between all the means, because you can see here that this vertical distance on this axis, right? So in other words, this is where we think the true mean lies for the 1 set group. This is where their true maximum squat lies for the 1 set group. And you can see that there's no overlap whatsoever with this category here, the 4 set group, right? So the mean for the 4 set group is supposed to be somewhere between here and here on this vertical axis. And you can see that there's no overlap between the 2, correct? There's no place where this interval crosses over with this interval. And because of that, we can say there's a significant difference between those 2 means, right? Which means that the average maximum squat for the 1 set group seems to be significantly smaller than it is for the 4 set group. And likewise, if you compare the 4 set group to the group for 8 sets, again, that 8 set group seems to be a lot stronger than the 4 set group, right? So again, there's no overlap between those 2 intervals. Also, there's no overlap with the 8 set group and the 1 set group, right? They're clearly very separate from one another. So it definitely appears that the 8 set group is the clear winner, and it then appears that the 4 set group is better than just 1 set, significantly better. So if you're actually going to create a diagram based on this drawing, you would say that if you're going from the small mean to the large mean, you're creating a diagram that goes in that direction, The smallest mean is mean 1, the second smallest is mean 4, and the third is mean 8. And nothing is connected. In other words, we don't have to put a bar here saying that 1 and 4 are not significantly different from one another. That would be incorrect to put that bar because they are significantly different, right? There's gaps between these two intervals, right? And there's gaps between this interval, and there's gaps between the interval for mean 4 and mean 1. So in other words, they're all separate and distinct, and the clear winner is mean 8, meaning that the strongest lifters at the end of the study were the lifters who did 8 sets of squats twice a week.